A hidden rupture zone beneath the Philippine Sea has reshaped everything we thought we knew. This once-dismissed stretch of trench may be capable of producing a tsunami larger than the 1976 catastrophe that claimed thousands of lives, with waves reaching 17 meters and crashing into shorelines in mere minutes. The Philippines has endured deadly coastal surges before, but this time even modern alert systems struggled under pressure. How did the country come so close to disaster once more? And what are researchers quietly acknowledging now? Today, we're diving deep into the hidden fault lines beneath the Philippine Sea, the scientists racing to map them, the cutting-edge technology that tracks seismic activity, and the emergency crews preparing to save lives when disaster strikes. By the end of this video, you'll never look at the ocean or the coastlines of the Philippines the same way again. Before we dive in, make sure you hit subscribe, because what we're uncovering today is just the beginning. You won't want to miss the warnings, discoveries, and shocking scenarios coming next. On a warm August evening in 1976, the earth below Mindanao lurched violently under a magnitude 8 quake. Within minutes, a wall of water, towering as high as 9 meters, swept across the shores of the Moro Gulf, erasing entire villages. Decades before this, in 1918, an 8.3 magnitude earthquake unleashed 7-meter waves that battered the Zamboanga Peninsula in Sulu. Towns were wiped out, fishing fleets flung inland, and entire communities were left grieving and cut off from the world. These disasters remain carved into the memory of the southern Philippines, retold through family stories and in monuments that face the sea. For many, the wounds left behind by these tsunamis never fully healed. Names of the missing continue to be spoken at annual memorials. Archival accounts from PHIVOLCS lay out the destruction in precise figures, but it is the testimonies of those who fled through the darkness, clutching children, seeking higher ground, that resonate most strongly. Yet despite this history, many still assume such catastrophes are rare or strike only other nations. The timeline, however, says otherwise. 1918, 1976, and now a new threat emerging from the same depths. The past is not far away here. It lingers as a warning written into every coastal settlement. October 2025 delivered a different kind of alarm to southern Philippines. Shortly after daybreak, seismic monitors recorded a magnitude 7.4 quake off Davao Oriental. Less than an hour later, a second jolt, this one magnitude 6.8, rattled the same offshore fault. Within minutes, PHIVOLCS issued urgent tsunami bulletins. Their warning system came under heavy strain as tide gauges along the coast registered waves surpassing 1 meter. Sirens wailed from Matiup to Surigao. Phones buzzed with evacuation instructions, sending thousands rushing uphill. Roads clogged with families gripping bags, infants, and documents, some barefoot, others still in nightclothes. In Davao City, responders scrambled to manage traffic and convert schools into temporary shelters. Police and barangay leaders moved from house to house, pleading with residents near the shore to drop everything and leave. Meanwhile, real-time tide gauge data streamed into the PHIVOLCS Operations Center. The numbers painted a clear picture, a surge powerful enough to inundate streets, damage boats, and threaten electrical lines. News broadcasts showed crowds gathered on high ridges, staring toward the horizon, searching for any sign of the sea pulling back. For many, the alerts arrived just early enough. But in some communities, confusion took hold as siren batteries died or telecommunications failed. Still, the mass movement inland was swift, evidence that decades of drills and collective memories had shaped instinctive responses. The October quakes exposed both the strengths and the flaws in the country's warning network, prompting deeper questions that would soon drive scientists back into the depths of the Philippine Trench. In the weeks that followed, a research group led by Professor James Pettigrew of the University of Bath released seismic findings that reshaped national risk assessments. Their work identified a previously unmapped section of the Philippine Trench stretching off eastern Mindanao and extending northward toward the Visayas. Using high-resolution sonar and deep ocean seismic arrays, the team built simulations modeling various rupture possibilities, each scenario more alarming than the last. What they found was stark. A magnitude 8.0 rupture along this stretch could generate waves as high as 6 meters. A magnitude 8.5 could double that, surpassing 10 meters. The most extreme case, a magnitude 9.0 megathrust, could produce waves up to 17.4 meters, tall enough to drown entire districts and major industrial ports. In such a disaster, the first tsunami waves could strike the Mindanao coastline in under 10 minutes. Manila Bay would have no more than 45 minutes before impact, barely enough time for mass evacuation. Professor Pettigrew's team traced the cause of these projections to the subduction zone itself. Where the Philippine Sea Plate sinks beneath the Sunda Plate, enormous stress accumulates silently over decades. When the fault finally snaps, large portions of the seafloor heave upward, displacing massive amounts of water in seconds. This mechanism lies at the center of the newly recognized threat. Our models show that a magnitude 9 Philippine trench event is physically plausible. The last one occurred more than 4 centuries ago, Pettigrew explained. Their findings transformed abstract warnings into concrete, measurable hazards that could be plotted onto specific cities and shorelines. They also raised urgent concerns about whether the country's detection systems could respond fast enough to such a scenario. Across the archipelago, early warning infrastructure sits on fragile footing. Tsunami-detecting ocean buoys are too few. Only a small number positioned along thousands of kilometers of coastline. Many have been offline for months, damaged by storms or left unrepaired. Beachfront sirens exist on paper, but a 2024 audit showed that more than 1/3 in the Visayas and Mindanao were corroded, missing batteries, or disconnected entirely. In some barangays, the only signal is a shouted message or frantic church bells. Dr. Maria Santiago of PHIVOLCS has spent years urging leaders to invest in more ocean instruments and real-time seismic monitoring. She now describes the newly identified trench segment as a glaring warning sign. This is not a question of if, it's a question of when, she emphasized. For years, her proposals for more buoys and improved sensors stalled due to political debates and budget delays. But with the recent findings, an uncomfortable truth has resurfaced. Science cannot protect communities if the data never reaches them in time. While experts work against the clock, another threat spreads even faster: misinformation. Following the October quakes, TikTok and YouTube filled with dramatic tsunami videos, many taken from past disasters in other countries or digitally altered to appear local. Some of these clips triggered nighttime evacuations in coastal towns. In others, residents ignored legitimate warnings because they assumed them to be fake. The result was widespread confusion, panic shopping, spontaneous stampedes inland, and a rising distrust of official announcements. In this environment, the boundary between preparedness and fear grows thin, and more often than not, the weak point is not the science, but the communication networks meant to carry its message. 3 possible futures now hang over the Philippines. Best case scenario: frequent minor quakes slowly release pent-up tectonic pressure, sparing the nation from a massive rupture. Waves may reach between 3 and 6 meters, but strong warnings and practiced evacuations keep casualties low. Hundreds may be affected, ports may be disrupted for days or weeks, and trade sees only temporary delays. Moderate scenario: a magnitude 8.3 quake strikes. Waves rise to around 10 meters. While some communities evacuate successfully, others react too slowly. The death toll reaches into the thousands. Manila's main port may shut down for over 100 days, with economic losses surpassing $16 billion and supply chains across Asia thrown into disarray. Worst-case scenario: a magnitude 9.0 megathrust. A 17.4-meter wave engulfs entire urban centers. More than 25,000 lives could be in danger. Trade could halt for over 200 days, sending shockwaves through international markets and leaving long-lasting scars. In the aftermath of the trench discovery, local disaster officers refused to wait for another quake. In Davao Oriental, the municipal council has vowed to repaint evacuation arrows and install fresh signs within 90 days, prioritizing routes that lead above projected flood zones. Funding requests for new ocean buoys and modernized sirens are moving through city halls, and PHIVOLCS is urging upgrades for communities still using outdated equipment. Large-scale drills are now scheduled twice a year, with schools and barangays practicing rapid evacuations and establishing clear communication channels. The preparation list continues to grow: backup siren batteries, handheld radios, pre-packed medical kits for shelters. Officials emphasize that readiness is non-negotiable. Every newly placed sign and every evacuation rehearsal serves as a promise that past lessons will not be forgotten. Today, more than 60% of the Philippine population lives near coastlines vulnerable to tsunamis that can arrive in minutes, not hours. Early warning has become a race against the laws of physics, demanding constant vigilance. The next earthquake will not only test the nation's scientific capabilities, it will test its resolve to be prepared.